Welcome. Yeah, thank you, Netflix. Always love being here. I remember, I think when I did the internal Netflix talk here a couple of years ago, looking for, so second time I can present in this wonderful venue. So I'm gonna go very fast and just 20 minutes to go to stuff that is new and noteworthy, just on Gradle Inc, Gradle Traction, and Gradle Features and Roadmap. Okay, let's get started. There's a new company behind Gradle. It replaces Gradleware for those who were aware of Gradleware. Same people, same culture, new name. Our name is now Gradle Inc. The new company name wouldn't be half as much fun without the right domain. So we now own Gradle.com. We're very excited about that, and we will put it to very good use, as I will quickly talk about later. We have a new Twitter handle. So if you're still kind of tweeting to Gradle.org, that's no longer the handle. Guess what the name is? At Gradle. So all extremely good news for us. It makes communication much easier, right? Just one name for everything. There's one other thing I'm very thrilled by. We have a new brand. That is how it looks like. The Gradle font bringing build happiness. And that is kind of important for us. We were thinking a lot this year, what is the culture of Gradle? What is the essence of what we're doing, right? And so for us, it has multiple meanings. It is the build master with Gradle elephant superpowers who needs to do hard, complex, sweaty work to build happiness for the developers, as the Netflix build team is doing, right? And not all build teams see developer happiness as part of their job. That's kind of interesting to observe, right? For us, it's one of the very reasons why we created Gradle, and that's, I guess, one of the very reasons why Netflix picked it up. And the slogan is also about putting developers in a much better place to build happiness for their users. And finally, it's also our commitment to you. And Gradle has seen astonishing growth. Right? Just to mention that we had 5.4 million downloads in 2014. Just in May, we had 800,000 downloads. We hope we will reach the 1 million mark soon at one point this year. So that's very, very, very exciting. And it is the golden age for next generation build systems. There is so much pain out there, right? And it's always fascinating how people and teams can get used to pain, even if it costs them dearly. And they always might say, well, it could be worse. You know, I can still see a little bit. I can still breathe a little bit. And this is not a good position to be in, right? This was never a position Netflix would accept to be in. But some organizations kind of got stuck into this. So, but the worst part of the story, and that's why I'm saying it's a golden age for next generation build systems, the octopus will get even more arms in the future, right? So software code bases are growing and growing. We see typical growth rates for some of the software stacks we are involved with between 20 and 100% per year. And I guess that is not an unknown growth rate here at Netflix, I would assume. So if you have serious problems now, with such growth rates, in a few years, these problems will totally kill you, endanger your very capability of shipping software. And those growth rates usually also mean that the teams are growing, right? Not just the code base. So that makes the inefficiencies ever more expensive as they are affecting more and more developers per team. The other thing is the set of technologies you need to support for creating software is diversifying more and more. What has been a pure Java stack 5 years ago, right, is now at least Java, Android, iOS, and you have JavaScript, Groovy, Scala. We all know that, right? What about native code, which is having a big revival just by Android NDK stuff, for example. And additionally, there is the architectural change towards a microservice architecture, which also adds significant complexity to the software delivery process. And the solution is to have a true multi-platform build system that is also a very powerful orchestrator, a polyglot build system. And that's one of the very strengths of the Gradle platform. There's a lot of exciting stuff we are working on to make Gradle an ever better tool. The best Gradle is still to come, right? We're super ambitious about the stuff we have in the pipeline. But what is important to understand, and Netflix is an organization that fully understands that, it will never be a free lunch to have an efficient enterprise build infrastructure, right? You are modeling your organization, which is a complex thing to model, as complex as your business logic, right? And we're trying to make this as efficient as possible. to allow you to enable continuous improvements for your software delivery process, but you have to pick up that responsibility. A classical example of what that means in terms of where you can go to is LinkedIn. So there's an interesting article from Wired connecting the commercial success of LinkedIn strongly with their investments into their build and delivery infrastructure. And we are very happy that Gradle is an important part of their infrastructure. So let's look at one of the things they have achieved. Right? In 2011, it took LinkedIn 30 days to release a new version of their software. They had that is a big software stack. I would still say by standards of 2015, this is way above average for that size of a software stack. But they were much more ambitious, although they were in a functional state, right? And they are now able to release at least 2 times per day. So 2011, it meant, just one metric that is interesting, a feature that was ready had to wait 15 days to reach a client, right? And now with 2 releases per day, it's half a day, right? This is from a factory perspective, a revolution. This is way beyond what lean production has achieved in the car industry. And that is the stuff we're talking about. And the interesting thing is, neither LinkedIn nor Netflix would consider the work as done. There's still so much that can be achieved, right? And so exciting time. Okay, that was the overview. Now let's start with some of the capabilities in Gradle that are new or that you might not be aware of, that we are pretty excited about and think are very valuable, plus some of the stuff we plan to do later this year or next year. So dependency management is a really interesting topic, right? Where I think the legacy Java dependency management solution are not solving key problems and it's completely basically ignored, and people kind of got used to that pain. But when you look at it, you think, well, actually, there should be better solutions for that. So for us, this is the year of Gradle dependency management. A lot of exciting stuff we have been added during this year, and some more exciting stuff to come. Okay, let's look at an example, right? Dependency substitution. So when you look at this simple build, right, there are 2 libraries. We're using JSON token and WireMock. You don't need to know what they're doing. I don't know either. And I need to figure out. Okay. And when we now go to the console and look at Gradle dependencies. Thanks. Wow. I feel like Obama now. So what you can see is there's Google Collections as a dependency of JSON token, right? And there is Guava as a dependency of WireMock. Well, who has that problem, right? In his organization, right? It's a classical problem. Why is there no good solution for that, right? The first problem is that the metadata, right? At the moment, it's the standard in Java world is POM.XML, is not telling this to the build system. It would be lovely if the dependency metadata could tell you, hey, actually, I'm Guava and I replace Commons Collection. We are the same thing, right? So, but what we offer on the side of Gradle is that you can say, okay, it's not in the metadata, so we add the metadata on the client side, potentially in a Gradle plugin, organization-wide plugin, and you can say, hey, Google Collections is replaced by Guava, right? And if you now, I'm so used to always looking here, I have to. If you now look at the dependency report, what you can see is if Gradle now finds Google Collections 1.0, it knows, hey, and Google Guava is also in the class path, it is replaced. So now you no longer depend on being fortunate that the order in the class path is correct, and when it changes, everything breaks, right? You now have a very solid solution to deal with this problem, right? And you can see, yeah, Guava 10.0 is the only dependency that is in the class path. So if you now remove WireMock, right, Gradle does exactly the right thing. When you run the dependency report again, you see now Google Collection is in the class path again because there is no guava, right? So all the workarounds with other build system to do some excludes, right? You would already now run into a problem, right? If you just exclude Google Collection. So leads to a lot of obscure problems. Gradle has a very straightforward solution to solve that problem. Okay, let's continue. Dependency selection rules. I love that, right? So that again, we have a super simple build script where we say, okay, we have a dependency on Hibernate validator on the latest version, right? So, and we're now running the dependencies report. What you can see is Hibernate validator is this what we call the requested dependency, and the selected dependency is 520 beta 1. And we're saying, damn, well, we want the latest, but not a better version, right? So how can you deal with this? That is where our dependency selection rules come in. So you can tell Gradle, hey, for when you're using dynamic dependencies, right? When you have a selected version where you have a set of candidates that fulfill the condition, in this case, any version of Hibernate validator that is in your repository, you can say, well, you can specify some rules according to which Gradle should select the right candidate. In this case, we're saying, hey, for all candidates for Hibernate validator, right? If the version contains the word alpha or beta, right? Reject those candidates. And let's see what this will give us. Okay. A pre-recorded demo, so I was talking too fast. I should follow my selections. In any case, you run this, and you can now see no longer a beta in there, but 513 final, right? And you can run this again with -i with info logging enabled, and then Gradle shows you which of the candidates were rejected, right? For which reason. Right. So you can also define such rules for all your components, right? Not just for a specific one that you say, I don't want to have any alpha or any beta. And yeah, in this case, you will have the same result, 513 final. You can do more interesting stuff. You can say, okay, actually, the 513 final version is causing problems, right, in our system, right? It's a bad version. It has a bug that is affecting us. So let's also reject that version, right, if it's a candidate. The selection reason is known bad version. And let's see what is happening. We run the report again, and now it's 512 final. And the reason why I'm so excited about this, yeah, we can now run it in -i mode, and you see all the candidates that are rejected and the reason why they are rejected. Okay, yeah, one more thing before I say why I'm so excited about this. And it's not just versions you can use as a selector, as a filter criteria, right? You can use the branch from which the dependency is built. You can use the status, whether this is a milestone, a dev release, and you can define your own status enumerations. So it's very, very powerful. And what is important to keep in mind, you can inject those rules depending on the environment, right? You can say, okay, for dev builds, it's fine to get alpha and betas, but for QA builds, I want to have different selection rules. So finally, snapshots are, the idea of snapshots is implemented in a way that they work in an organization, right? And are not just a toy. That's how I see it, right? So I think those selection rules are extremely important for that. That you can somehow model the staging process your software, your organization is using for staging the software on their way from development to production. So and And we will build higher abstractions eventually on top of those low-level rules that you can specify, right? To make certain processes easier to model, but in any case, you can use this today, right? You just have to implement some logic around that, and I think it will add a lot of value to many organizations. Okay, last thing, also very excited about, fluent dependencies. What is this about? This is about multi-project builds, and we have an example multi-project build here. So when you look at this example build, it's a tree sub-project, right? Sub 1, sub 2, sub 3. And you have to keep in mind, we have organizations up to 4,000, right, sub-module builds, right? So this is just an example build. And what people are facing when they have builds with many sub-modules, for example, the IDE doesn't scale very well with that, right? So if you have an Eclipse or in IntelliJ, multiple hundred sub-projects, the refresh will take a long time. It also means you always have to have the whole code checked out. So it is, although it might make sense that you have a single code base, right? For very often developers only want to work with a subset, and that is now what we are supporting with fluent dependencies. So what you can now do, so if you look at the dependency report, what you can see, kind of interesting, those are project dependencies, right? But with fluent dependencies, project and external dependencies are considered almost the same thing, and you can decide what you want to have. In this case, we only work with project dependencies, which means if you build the whole thing, right? If you say Gradle clean build, you see that all the projects that are required are built, right? So locally, right? All the binaries are built locally that are needed for this build. And if we now removing, let's say sub-project 2, right? When you now look at the dependency report, what you can see is that Gradle realizes, hold on, sub 2 is no longer replaced by a project dependency because the project doesn't exist, right? And when you build the whole thing, you now see only sub 1 and sub 3 is built, and sub 2 is retrieved from a repository. But the very cool thing of this feature is we still know that sub 2 has a dependency on sub 3, and sub 3 is not taken from a repository but built locally because it's available locally, right? So, and I don't have time today to go into the details how this is implemented, but it's very powerful. With that, you could theoretically, for example, implement functionality that you say, okay, I replace a project dependency with an external dependency if they have been built against the same commit ID. Use it basically as a company-wide distributed cache for jars and things like that. It's a very, very powerful tool. And we will build up higher level abstractions on that, but again, it's available to you right now, and you can do very, very cool stuff with that. So Gradle has a very rich plugin ecosystem, and especially in regard to dependency management, and Netflix is one of the core contributors to that. They have very, very powerful plugins where they build higher level abstractions on the low level, basically Gradle capabilities, the dependency log plugin, the blacklist plugin. Rob will talk more about this later on. So that there are and quite a few new ones I just learned about recently. Okay, another thing we're working on right now, and it's finally a reality because the code is in master. It's not fully finalized yet. It's variant-aware dependency management. So dependency management where not just group, name, and versions are part of the resolution process, but also target platform, processor, debug or release binaries, and this will include compatibility rules, right? So when you are building for 64-bit, let's say, for native, and you have a dependency on foo, we will automatically look for the right foo for the foo that is also built with 64-bit, but if it's not available, we take the 32-bit version. The other way around, we would say, if it's only 64-bit and you build for 32-bit, the build would fail, right? So that is very exciting. Variant-aware dependency management, especially with Java 9 coming in Jigsaw, this will also be relevant for the Java world. And you should expect to try this out at the latest when I have to present it at Java 1 in 2 months. So another thing we are working on is our new component model. Again, I don't have time to go into this. It will be a much richer model to capture the requirements of or to model deeper what a software project is, right? And variants play a key part in this. Variants like target platform and like, you know, the JDK version, or is it for WebSphere or for JBoss, or in the native world, all the different variants you have. It's a concept Android introduced into the Gradle world, and we now basically applying the same great principles that the Android plugin has introduced to Java and C++. Okay, the next thing I want to talk about is stuff we're doing directly for helping developers to have a more efficient workflow. So one example I want to show you is about the new continuous mode introduced in Gradle 2.5. So this is not a Java project, it's an ASCII Dockter project, right? A project where you create documentation. And so if you look at the tree, well, it also has some Java code, so it's a mixture, right? So you have some Java code in there, and also a source docs directory where you are using the ASCII docked metadata or markup format for creating documentation. And come on. So if we look at this in more detail, how such an ASCII Dockter file looks like, right? This is I guess many know this format already. It's the new format O'Reilly uses for all their books, for example, right? So what you now can do with Gradle, you can now say, hey, Gradle, generate HTML out of that markup format, right? And let's do this, right? And now we can open the HTML that was generated. And here we go. Okay, so let's change the ASCII Dockter text. Let's do something exciting. Isn't that something? And let's run the ASCII Dockter task again. Let's refresh. And I accept that you're not excited yet. That's okay. So now we do something new. We run the ASCII Dockter task in continuous mode. Right? And you see, waiting for changes to input files of task. And now, let's do something really exciting. We save this, and we just go to the browser, and we refresh, and here we go. Don't need to run anything. Right? So, and continuous mode introduced with Gradle 2.5, and we save again, and again you don't need to do anything. It's automatically rebuilt the HTML, and when we go back to the console, you can see, right, change detected, executing build, and this was the other change that was detected. So why this is, there are watch plugins out there for quite a while for Gradle, right? But with those plugins, you always needed to specify a file pattern for what to watch for, right? Which is kind of a shame because the Gradle tasks have a rich input and output model, right? And now you can run any Gradle task in continuous mode, right? And you don't need to specify anything else, and Gradle knows exactly what to look for. And so that it's a wonderful feature, especially once we have IDE integration for that. It's almost extending IDE functionality. If you think about some complex source code generation tasks, right? Once you change certain XMLs, you want to have source code generated, right? Do you want to write an Eclipse builder for that, or do you